In this lesson, it's going to be a little bit of a brief introduction to graphing sine and cosine. We're not going to mess with any of the graphs yet. It's more just what are they, what do they look like, how do they look the way they do. So, just like any kind of introduction to a graph, before you really kind of understand that there's a pattern to it and what does it look like all quadratics have a certain look, all linears have a certain look, and initially you plotted a bunch of points, but as time went on, you figured out there's a better, more efficient way to do it. Is there a pattern? Is there a starting point? Those types of things. So sine and cosine is no different. So there's a certain look to sine graphs, there's a certain look to cosine graphs, and you're going to see that they're pretty similar to each other. The points that we're going to plot are, there's an infinite amount of them, but we're going to plot kind of some of the quote easier ones, where we're going to plot 0, pi over 2, pi, 3 pi over 2, and 2 pi. And those actually just end up being points kind of on the axis of our unit circle. So if we start with sine, the x refers to our angle that we're plugging in, not like an x value. It is an x value, but sine again refers to y values on the unit circle. So if we're graphing 0, sine of 0 degrees or 0 radians is the y value, so it's the 0. So sine of 0 is 0. We want the y value at pi over 2, which is 1. We want the y value at pi, which is 0. And then we want the y value at 3 pi over 2, which is -1. And then back to 2 pi, which is the same thing as 0. So that's one full cycle all the way around. So one full cycle on this graph is going to have a very, very distinct look to it. So the way I go about doing it, and we'll talk about details on the next video about why we do the way we do, is there's going to be 5 main points on every single one of these sines and cosines. Your x-axis, or your y-axis, is going to be kind of the first point it's going to start on. So that'll take care of the first point, and then there's 4 others. So I just equally out make 4 marks, and then 2 pi ends up being the last, and if I cut that in half, that'll be a pi, and if I cut that in half, that'll be a pi over 2, which works out to be this scale perfectly. So 1 pi over 2, 2 pi over 2, 3 pi over 2. So if I plot these points, the sine and cosine graphs are going to fluctuate between a -1 and a +1. Those are going to be the high and the lows of this. And so sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is back to 0. So the graph for this looks like that. So that's one full sine curve. And so this thing would repeat itself. I'm going to draw that down here in a second because there's some terminology and some meaning that we have to make sure we understand. But that's one full cycle of a sine curve. And then cosine is going to be very similar to it, where if we plug in here, we have cosine refers to x values. So if we do sine of 0 radian or 0 degrees, we're looking at 1. If we do sine of pi over 2, we're looking at 0 because it's the x value. Sine of pi is -1. 3 pi over 2 is 0. And 2 pi goes back to the beginning. So I do the same for equivalent marks out. 2 pi, pi, pi over 2, and 3 pi over 2. And again, sine and cosine both fluctuate between a -1 and a +1. And cosine starts at a high point, and then it goes to pi over 2, hits a low point at pi, back to 3 pi over 2 if you're looking at the points, and then finishes off back at a high point. So it's not a parabola, so don't make it kind of look like it keeps on going. It's actually hitting a high point, so it would curve, and then it hits a high point again. All right, so that's one full cycle of a cosine. So if we go back to the idea of sine, And let's say we graphed more than this. There's some terminology that we want to talk about. So if we do our 1, 2, 3, 4, 2 pi, pi, and then 1, 2, 3, 4, this would be 3 pi, this would be 4 pi. And just to kind of not keep it so busy, we won't put in the points in between, or the scale in between. We're going to plot the points in between, but not the scale in between. So let's say we graphed sine. Sine starts here, goes to a high point, back to the middle, low point, back to the middle. So that is one full cycle, because it's one time around the unit circle. But if you continued, it would continue with that same cycle. So then it would go back to a high point, to a low point, or a middle, then a low point, and then a middle. And so a sine curve and a cosine curve just do this fluctuation time and time and time and time again. If you've ever been in a physics or a music kind of a thing, it's a sound wave, a radio wave, all sorts of different things have this very similar sine cosine look to it. Some terminology that we have is, if you're going to talk about, there's a terminology called a period. How long does it take for one full cycle to happen? Well, for our sine and our cosine, it happens from here to here is one cycle, so we call that a period. And all sines and cosines normally have a period of 2 pi. That's going to be messed with, but that's how it normally starts off as. Second piece of this is that you have this kind of midline, we call it, that cuts your graph in half. That midline can shift up, down, depending upon some values in your original equation. But from here, your graph fluctuates that far up and an equivalent value down. That is known as an amplitude. All right, so this graph can, the whole graph can move up and down, shifting your midline, but not affecting the amplitude. Your graph can stretch, but it would stretch equivalently on top and the bottom from the midline, so your amplitude gets stretched up and down. Your graph, the period can be messed with, so kind of the horizontal distance can stretch out or stretch in, depending upon what numbers you got going on. And then the whole graph can shift left and right. So that's known as a phase shift. So there are pieces of where all of these things come from. And this is where we're going to get to on the next video, next lesson, is back in the day, you did transformations with a quadratic. And you had your h and your k, and that referred to your vertex. Well, you're going to have something similar. It's not a vertex, but the same kind of transformations are going to occur. So this was your left and right shift, this was your up and down shift, and this vertically stretched your graph or reflected it, or it could have compressed it. Well, you have similar fields to this. That a value is the same as this capital A value. But for us, in sines and cosines, it's going to be referred to as an amplitude. The k value, the other piece of your vertical shift, is the d value. That is affecting your midline. So if it's +1, your whole graph is going to get shifted up 1 and then fluctuate from there. So it's your vertical shift. So that k and that d are the same concept. The a and the a here is the same concept. So these two are vertically affecting your graph. All right. And now the pieces on the inside. Anything on the inside horizontally affects your graph. So the b is going to specifically affect your period. So it affects the period. The period on every single one of these sines and cosines are initially going to be 2 pi, but they're going to be divided by b. And we'll talk about that, why that happens later on the next video of graphing. But it is your horizontal stretch / compression. All right, so, and then the c is just like the h, where it's going to shift your graph left and right, kind of always in an opposite manner. That is what we call a phase shift. It's your horizontal shift. So these two are going to horizontally affect your graph. So anything on the inside horizontally affects, anything on the outside vertically affects. And then on the next lesson, we're going to actually manipulate a whole bunch of these things. But that's just a brief idea of what the graph looks like, where it comes from. It comes from pieces of the unit circle. And here is the basic idea that it's going to be a sine curve or a cosine curve, and it just kind of does this over and over and over and over again. And these are some of the terminology and the pieces to it. And then we're going to mess with all that on the next video. Thanks.